Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will do some more questions on definite integrals as the limit of a sum. Here is the first question. In this definite integral, that's integral minus 1 to plus 1 e raised power x dx, we have fx equal to e raised power x and nh is equal to upper limit, that is 1, minus lower limit, that is minus 1, which is equal to 2. Also, f of a plus rh, that is f of minus 1 plus rh, is equal to, now replace x by minus 1 plus rh, we get e raised power minus 1 plus rh, or that is further equal to, it is e raised power minus 1 into e raised power rh. Okay? Now, from the definition of definite integrals as the limit of a sum, we have integral minus 1 to plus 1 e raised power x dx is equal to limit h tends to 0 h times summation r running from 0 to n minus 1 f of a plus rh, that is equal to limit h tends to 0 h times summation r running from 0 to n minus 1. Now, instead of f of a plus rh, we have e raised power minus 1 e raised power rh, so we can write e raised power minus 1 e raised power rh, or that is further equal to this limit h tends to 0 h times e raised power minus 1, as e raised power minus 1 is free of r, so we can write it here, then summation r running from 0 to n minus 1 e raised power rh, which is further equal to, it is limit h tends to 0 h times e raised power minus 1, then when r is 0 we get 1 e raised power 0, that is 1, plus when r is 1 we get e raised power h, plus e raised power 2h, and so on, plus e raised power n minus 1h. Okay? Now, this is further equal to limit h tends to 0 h times e raised power minus 1. Now look here, we have 1 plus e raised power h plus e raised power 2h plus so on plus e raised power n minus 1h. This forms a geometric progression with first term equal to 1 and common ratio is equal to e raised power h. We know that the sum of n terms of a geometric progression is equal to first term, that is 1, into 1 minus common ratio when r is less than 1. So it is 1 minus common ratio, that is e raised power h raised power n, where n is the number of terms, divided by 1 minus r, that is common ratio, that is e raised power h. Okay? Now that is further equal to, it is limit h tends to 0 here we can write it as 1, which is h e raised power minus 1. It's 1 minus e raised power nh divided by, now take minus common, so we can write minus times e raised power h minus 1. Okay, now this is further equal to limit h tends to 0, h times, or we can write it e raised power minus 1, 1 minus e raised power nh. Now instead of nh we can write 2, as nh is equal to 2, so we get e raised power 2 divided by minus e raised power h minus 1 divided by this h. Okay, now e raised power minus 1 into 1 minus e raised power 2 is free of h, so we can write it as 1 minus e raised power 2 divided by e whole divided by minus times limit h tends to 0, e raised power h minus 1 divided by h. So this limit is equal to 1, so we get 1 minus e raised power 2 divided by e whole divided by minus times 1, that is minus 1. So we can write it as minus times this. Okay, which is further equal to, that is minus 1 plus e square. It's minus 1 plus e square divided by e. Okay, now we write here. That's further equal to, which is e raised power 2 divided by e, that is equal to e. Then we have minus 1 divided by e. So that's the answer. Therefore, value of this integral minus 1 to 1 e raised power x dx is equal to e minus 1 by e. Okay, that completes the question. Now let us evaluate one more definite integral. In this definite integral, that's integral 0 to 4 x plus e raised power 2x, we have fx equal to x plus e raised power 2x. Also, nh is equal to upper limit, that is 4, minus lower limit, that is 0. It is 4 minus 0, which is equal to 4. Okay, also f of a plus rh is equal to, it is f, a is lower limit, so that is equal to 0. It is f of 0 plus rh, which is equal to f of rh. Now replace x by rh, we get rh plus e raised power 2 times rh. Okay, now from the definition of definite integrals as the limit of a sum, we have integral 0 to 4 x plus e raised power 2x dx equal to, this limit h tends to 0, h times summation or running from 0 to n minus 1 f of a plus rh, that is equal to limit h tends to 0, h times summation or running from 0 to n minus 1 Then we have f of a plus rh, and that is equal to rh plus e raised power 2rh. Okay, that is further equal to, it is limit h tends to 0. Now it is h into h, that's h square summation r running from 0 to n minus 1 r, then plus h times summation r running from 0 to n minus 1 e raised power 2rh. Okay, now this is further equal to limit h tends to 0, h square summation r running from 0 to n minus 1 r is equal to n into n minus 1 divided by 2. Then we have plus h. Now here, when r is equal to 0, then we get e raised power 0, that is equal to 1. When r is equal to 1, we get e raised power 2h. When r is equal to 2, we get e raised power 4h. So on. When r is equal to n minus 1, we get e raised power 2 times n minus 1h. Okay? Now this is further equal to, it is limit h tends to 0. Now here we have h square, so we multiply one factor of h to this n and one factor to n minus 1. So we can write nh into nh minus h, okay, divided by 2 plus h into, now here we have 1 plus e raised power 2h plus e raised power 4h plus so on plus e raised power 2 into n minus 1h. This forms a geometric progression with first term equal to 1 and common ratio is equal to e raised power 2h. So, and we know that the sum of n terms of a geometric progression with first term equal to 1 and common ratio is equal to e raised power 2h is, it is first term, that is 1, into 1 minus common ratio when r is less than 1. It is 1 minus common ratio, that is e raised power 2h raised power n, and is number of terms, divided by 1 minus common ratio, that is e raised power 2h. Okay, so this is further equal to, this limit h tends to 0. Now we have nh, and instead of nh we can write 4. So we can write 4, it is 4 minus h divided by 2 plus h into, it is 1 minus e raised power 2nh. So we can write e raised power 2. Instead of nh we have 4, so we can write 4 instead of nh, divided by 1 minus e raised power 2h. Okay, this is further equal to limit h tends to 0, it is 4 minus h divided by 2 plus, it is now take minus common from this denominator, so we can write it minus 1 minus e raised power 8 divided by e raised power 2h minus 1 Now we write this h here and we multiply h by 2 and write 2 here also, so that 2 by 2 is equal to 1. Now apply limit as h tends to 0. We get 4 into 4, that is 16, divided by 2, minus, it is 1 minus e raised power 8, then we have 2, this is free of h. Here we have h, so we can write limit here, limit h tends to 0, e raised power 2h minus 1 divided by 2h, that is equal to, it is 8 minus 1 minus e raised power 8 divided by 2. Now this limit is equal to 1, limit h tends to 0, e raised power 2h minus 1 divided by 2h. So this is equal to 1. We get 8 minus 1, minus minus is plus, plus, or we can write it like this, it is 8 into 2, that is 16, it is 16 minus 1 plus e raised power 8 divided by 2, okay, and that is equal to 16 minus 1 is 15 plus e raised power 8 divided by 2. That is the answer. So value of this integral 0 to 4 x plus e raised power 2x is equal to 15 plus e raised power 8 divided by 2. That completes the question. Now in my next lecture we will discuss fundamental theorem of integral calculus. Till then, take care of yourself. Thank you.